Let's take a look at a few properties of logarithms. These are the basic properties that we have for logarithms. The product rule basically says that if we take the argument of a logarithm, that we can separate it into two separate logs, but put it as the sum of those logs. The quotient rule says that we can take the argument of a logarithm that is division and that we can separate it as two separate logs, but when we separate it, we'll separate it using subtraction. Also, the power rule for logarithms says that if our argument has a base and a power only, that we can take that power and put it in the front as a factor. In other words, we can multiply it. So we can take y and put it in the front, and now we can rewrite our logarithm. The change of base rule for logarithms basically says that we can use any base that we wanted to. As an example, if we had log base 2 of 30, that we could rewrite it with a different base. So we can say log base 5, just making up a number. So we've changed the base, but we're going to use the argument as one of the arguments, and we're going to use the base as the other argument. So when we work out this same problem here, these two individual problems with a base of 5, and we divide them, we're going to get the same answer as log base 2 of 30. That's all the change of base rule or property for logarithms is. In order for us to prove these properties, we have to remember the properties of exponents. Remember that when we multiply with the same base, that we're just adding the powers. And when we raise a base, when we raise a power to another power, we just multiply those two powers. And also, when we divide a power, or rather two values that have the same base, we're going to subtract the powers. We're going to use those properties. Suppose we started with that x is equal to b to the m, and that y equals b to the n. So let's say we took a log on both sides. We know that log base b, we can use a base of b because we're already using a base of b up at the top. Log base b of x is the same as log base b of b to the m. We're just doing a log on both sides. Also, we know that log base b of y is equal to log base b of b to the n. So from what we knew from exponentials and logs, that log base b and base b are inverses of each other. So we know that m is the same as log base b of x. On the other side, same thing. Log base b and base b are going to cancel each other out. So we know that n is the same as log base b of y. So let's continue with what we know. So if we have log base b of x times y, this is the same as saying log base b of, remember, x is b to the m. So it's the same as saying b to the m times, remember that y is the same as b to the n. So times b to the n. Our product property says that we can just add the powers if we're multiplying and the bases are the same. So this is like saying log base b of b to the m plus n. Basically, this tells us that, again, the log base b and the base b are going to cancel each other out. So we're just left with m plus n. And now we have over here, we still had the log base b of x times y. So remember what m and n were equal to. M was the same as log base b of x. So we're going to replace this m with log base b of x. And that n was the same as log base b of y. So we're going to replace this n with log base b of y. So what we know is that log base b of x times y can be separated as log base b of x plus log base b of y. How can we use this property? Suppose that we were asked to expand log of 3x. This is going to be the same as, remember that we're multiplying here. So whenever we're multiplying our argument, we should be able to separate it as the sum of two logs. So we should be able to separate it as log of 3 plus log of x. Let's try another one. At any point, you can pause it and try it yourself and see if you come up with the same answer I do. So why don't you try and see if you can figure out what log of x squared times y would look like. All right, so the answer here, since we're multiplying, we should be able to separate it as addition. So it'll be log of x squared plus log of y. To derive this particular property, we're also going to use exponent rules. Let's say we start off the same way. X is equal to b to the m, and that y equals b to the n. Just like before, we can say that the log base b of x has to equal m, and the log base b of y has to equal n. So we could say that the log base b of x divided by y, we're just substituting. Remember that x is b to the m, so we're going to have basically log base b of b to the m over, and remember that this is what y is equal to. So it's going to be over y, which is b to the n. And from what we know, when the bases are the same, we subtract the powers. So this is the same as saying log base b of our new argument, which is b to the m minus n. From what we know, base b cancels out with log base b. They're inverses of each other. So that's going to give us m minus n as a result. And we already had log base b of x over y on this side. So if we replace what m and n are equal to, remember that m is the same as log base b of x. So log base b of x minus, and remember that n is the same as log base b of y. So it'll be log base b of y. And we already had log base b of x over y on this side. So now we've proven, or we've derived, our log rule. Let's see how we can apply this rule. So suppose that you are asked to expand log of 10 over y. What would that look like? Well, because this is division, our argument has division, we're going to use subtraction to separate our log or to expand our log. So this would be log of 10 minus log of y. So you're welcome to try this next one. Pause it if you would like to and try and see if you can come up with the same answer that I do. So suppose that we had log of a squared over b cubed. So this is going to be the same as log of a squared minus log of b cubed. We're going to use a similar strategy to derive this one. Let's say we said that x is equal to b to the m. Then that means that if we wrote down log base b of x to the z, that this is the same as saying log base b of b to the m raised to the z power. When we do power to power, we have to multiply them. So this is the same as log base b of b to the m times z. This we know is going to cause the log base b and the base b to cancel out, so we're just left with m times z. So we know that from what we have here, that this has to equal m times z. So log base b of x to the z is equal to, and remember, m times z is the same as z times m. So it's equal to z times m. But remember that m, from our previous example, that m is the same as log base b of x. So what we have is that this is equal to z times log base b of x. So we've just proven our power property for logarithms. So how would we use this particular property? Well, we would, as an example, let's say we had a logarithm that had a base and a power. What we could do is we could say, to rewrite this, we could take that power and move it to the front as multiplication. So this is basically the same as 3 times log of x. What if we had log of y to the 4th power? What would that look like? Pause it and try and see if you can come up with the same answer. So this 4 would get moved to the front, and it would become 4 times log of y. Suppose we started with the premise that log base b of x is equal to a. If we exponentiated both sides, so we would have base b on this side and base b on that side. Remember, log base b and base b cancel each other out. So we're left with that x is equal to b to the a. Now, let's say that we took a logarithm again, but this time let's use a base other than b. So we have log base c of x on this side and log base c of b to the a on the other side. So we're using basically a different base, and the fact that it's an equation, we're doing the same thing on both sides of our equation. Notice on the right side of the equation that we can use a property of logs to work on this, to get this to be something different. Remember, we said that if our previous property, if we have a base and a power, that we could just go ahead and move that power to the front as multiplication. So this is basically the same as a times log base c of b. So if we rewrote everything, now we have log base c of x. So let's get everything with the same base on the same side. So let's divide this side by log base c of b, and the other side by the same thing, log base c of b. Then on the right side, these will cancel out. So let's just rewrite what we have. So what we know is that a is equal to log base c of x divided by log base c of b. But when we started everything off, remember we said that log base b of x was a. Remember what we had over here? We said log base b of x was a. So we should be able to replace a with this particular logarithm. So what we have is that log base b of x is equal to log base c of x over log base c of b. So we have just derived our change of base formula. So here are some examples. So remember that if we did log base e is about 2.718 of some number, let's say it's 9, that this is the same as writing ln of 9. So they mean the same thing. So suppose that we were to rewrite this in a different way. So instead of a base of e, let's say that we wanted our new base to be 8. So what would this look like? Well, what it would look like is that we would use our change of base formula and say we want the base to now be 8. We know that our argument is 9, so that would go in the numerator. And we know that our base is e, so that would go in the denominator. So let's say that you were to try one on your own. Try to apply the change of base formula to the natural log of 7. See what you'd come up with. So what we have is, let's say that we want to change the base to 4. So we would have log base 4 in both the numerator and denominator, and we would use 7, our argument, in the numerator, and the base we're currently using, which is e, we would use that in the denominator. Let's try one more. And of course, you can pause it and try and see if you come up with the same answer that I do. So let's say we had log base 2 of 37, and we wanted to come up with this same result or the same problem, but with a different base. Let's say we want to rewrite this in base 5. What would it look like? So we have log base 2 of 37, and we said that we want it to be base 5, so we will put log base 5, log base 5. Our current argument is 37, and our current base is 2. So if we were to work this out, then we would come up with what was equivalent to log base 2 of 37.